Achilles, Shenza, Pierce.
I did run my whole face over by then.
You said 65 tonight.
Wait, I don't get how you. All right, ladies and gentlemen, you have got 20 minutes to work on the combined gas law problems in your packet. Get to work. If you have questions, please let me know. All right. Then we will get to the question of the day after you have had your 20 minutes. So go to work, ladies and gentlemen. Ladies and gentlemen, someone actually gave me this today, and I'm wondering your thoughts on if you think it is accurate or not. They said this described me well.
Yeah.
All your grades just dropped.
All of them.
All of them.
All left you right.
It's not a bad thing. How's that a good thing?
Oh my goodness.
It's not good, but it's not. Your grade just continues to drop, Phoebe. Shush.
I'm okay with gymnastics.
Really? So you want to take the class again with me? Okay. Go to work. Can't believe you agreed with that. Is today. I need my packet. Hang on. Okay, I can do this. Okay. Here's a problem with combined gas laws. Did I show you this one yesterday or no?
Oh, I think you did.
Okay, let's go to the next one then, because we've already done this one. Okay? So, you've got a gas, sulfur trifluoride. Somebody, what's the formula for sulfur trifluoride? What?
SF3.
SF3, sulfur trifluoride. Please do not forget that. The next unit we go to, you are going to need those names and those formulas and all that stuff back again. Okay? Unit 7, when we go to it, puts everything that you have learned all year long together. Everything. Okay? Everything. Sulfur trifluoride gas is under the following conditions. 0.986 atmospheres, 31.6 degrees Celsius, and a volume of 2.36 liters. Now, the only way that I can mess with you is if I take and do what I did in this problem, which is give you conditions that are not in the same units later on. And that's what has happened here. So originally, ladies and gentlemen, our conditions were this pressure, this temperature, and this volume. we can put all of those things on one side of our equation. So we can put 0.986 ATM. We can put 2.36 liters. We can put a temperature of 304.6 Kelvin. Okay? On the other side, we have a different set of conditions. Those conditions are 1.31 atmosphere and a volume of 1,236 milliliters. So that's going to be the P2 side. Now, the pressure is 1.31 atmospheres. That is not a problem. Why? Because those are in the same unit. But our volume is 1,236 milliliters. You need to convert that into liters with this, ladies and gentlemen. Now, if you can do this in your head, I don't care. But this has to be in the unit of liters, otherwise you cannot work this problem. Okay? Unless you change this one over here to milliliters. I don't care. They got to be the same on both sides. So that is why I am doing that. And then I'm putting T2 on the bottom here. I'm solving for it. By the way, this one, it wants it in Celsius. Christopher, remember when you were asking me before?
Yep.
Here's a problem where you got to put it in Celsius at the end. Okay? So now, cross products are equal, ladies and gentlemen. That is the easiest way to do the math on this. So I'm going to take 0.986 atmospheres times 2.36 liters times T2 equal to 1.31 ATM atmospheres, 1.236 liters, 304.6 Kelvin. Now, again, I'm sorry, ladies and gentlemen, I did not explain this to you, okay? Mathematically, if I put these both in parentheses, or if I put a multiplication sign in between them, it means the same thing, okay? It means the same thing. So, I am multiplying these three numbers together. Whether you put them in your calculator in parentheses or you just put a multiplication sign in between them, I don't care. But that's all we're doing with those. We always, when we get to this point, isolate our variable. Here's our variable, T2. Isolate means to get it alone on one side. The way that happens is whatever math I'm doing to it on this side, I do the opposite. I'm supposed to multiply it by these two numbers. I divide it by these two numbers. So I divide it by 0.986 ATM. And I divide it by 2.36 liters. These cancel. What I do to one side, I got to do to the other. Now, the order that I do them doesn't matter. The order that I put them in doesn't matter. But again, one student pointed out, if you put these both in parentheses, after you hit the divide by sign, you're going to get the wrong answer. Because you're not telling your calculator to multiply those together before they finish dividing. So you would have to put it in your calculator this way. Parenthesis, the number, times the other number, close the parenthesis. That is the only way you will get the correct answer out of your calculator. Did someone get a correct answer for this? And can you tell me what the temperature was in Kelvin? 211 Kelvin. It wants it in degrees Celsius. What do we do? So what do we get? Now, sig figs, how many here? How many? So how many sig figs in your answer? How many do? Why did you take the biggest number?
Oh, 3.
So what's wrong with my answer?
It's in two.
So how do I make it into 3?
Point three, point. I mean, not point.
0.0. Again, it might be 0.1 because I believe this worked out to be like
Well, it was like
210.9 or something. Out again, you put down 62.1, negative 62.1. I put down negative 62. I'm going to give it to you. Questions? Yes, no, maybe so. Okay. So now, in all of these problems, every one of these, we are comparing one set of conditions to another, correct? Here's a pressure and a volume. Here's a new pressure. Figure out what the new volume is. One set of conditions to another, correct? One set of conditions to another. Even here, we're comparing one set of conditions to another. There's always one set of conditions that we know, ladies and gentlemen. There's always one set of conditions about a gas that we know. Can anybody tell me what it is? Think last unit. What set of conditions did I give you about a gas in the last unit? What? STP. STP. They're a set of conditions. They're a set of conditions that you can always compare to if you wanted to, ladies and gentlemen. Always compare to if you wanted to. So P1, V1 over T1 is equal to P2, V2 over T2. But here's the thing, on this side, I could put in STP. Anybody remember what the temperature was at STP? Zero degrees Celsius. What's 0 degrees Celsius for a temperature? 273. Guys, I hope you're getting this, because this is something new you haven't been taught. Can somebody tell me what standard pressure is? That it? What if we're in PSI?
14.7.
What if we're in atmospheres?
1.2.
What if we are in KPA?
101.3.
Now, a gas could always be under standard conditions, which means I can put a number in for T here. I can put in 273, correct? Where do these numbers go? In for what? P2. Wait a minute, I still need V2. What's V2? V2 equals 22.4 liters. In other words, we can put a set of conditions in here, ladies and gentlemen, to compare any gas to. Now, technically, we are missing one thing. What are we missing? What variable is not in here? The amount of gas. Where would the amount of gas go in this formula? P has always been on top every single time. V has always been on top every single formula we have had. T has been on the bottom every single time. Where's N go? Equals what? No. Close.
T2 over T2.
Ladies and gentlemen, this is called ideal gas law. Because you know what? For this P, I can put in these numbers all the time. For this T, I can put in 273. Now, does the volume ever change at STP? What would cause the volume to change? Why would a gas take up more space at STP? Well, it takes up 22.4 liters when there's how much gas? 1 mole. What if you had 2 moles of gas? So wait a minute. One mole, 22.4 liters, correct? 2 moles would be what? 3 moles. What if we only had a half a mole?
11.2.
What's V divided by N here? 22.4 divided by 1.
22 point.
What's 44.8 divided by 2? What's 67.2 divided by 3? What's 11.2 divided by 0.5? Guess what? That never changes, does it?
Oh, wow.
That means, ladies and gentlemen, that on Monday, all of this side right here becomes a true constant. A true constant. No more of this a constant if we don't change this and we don't change that. It becomes a true constant. One number to represent it. That's what we're going to do on Monday. That's what we're going to do on Monday. Okay? All right. So, questions before you take your quiz today? No, I can't give you an A. They told me I'm not allowed to give out A's. However, you could earn an A, and then I will be forced to give it to you in spite of my better judgment. What? Okay. Take out your calculators, put away your computers, take out your periodic tables, put everything else away.
Oh, you can see it back then. Let's make it with my two that you did.
Two.
Give it
Two sheets. What? Oh.
Do that.
Wait, just one, right?
You can have two sheets. One periodic table, one solubility chart on your desk. You now have three if he hands you that one.
No. I was just. I need the chart.
Yeah.
Oh, those are really nice.
Good, you should let him though.
Oh, Bruno Mars.
Good, let him.
You should.
Oh my
But
god.
you are doing well.
Oh, that's me. Wait.
Oh, well, they.
On the front side, ladies and gentlemen, the only thing that you need to put in those boxes are increase, decrease, or constant. That's it. Now, if you're you're sitting there going, well, how do I know if it increases or decreases? I don't care if it increases or decreases, as long as you tell me that the other thing goes the proper direction according to what you say the first thing did. So if it's a inverse relationship and you're telling me one thing goes up, the other thing should go down. I don't care which one you say goes up and which one you say goes down. Now you got to get the right variables, obviously. But I don't care if you tell me they're both increasing because it's direct or they're both decreasing because it's direct. Okay? On the back side, ladies and gentlemen, at the top are the standard pressures for you. Okay? I will put one thing on the board. I don't think you need it. I will put that on the board for you in case you do need it, but I don't think you do. But please remember, the problems on the back are graded on setting your problem up correctly. If you have to go to Kelvin, doing that correctly, and then giving me a correct answer in the correct amount of sig figs with the correct unit. Go to work, ladies and gentlemen. If you have questions, raise your hand. I will be happy to come over and try to assist you any way that I can.